if you have read through it, that's good. So have not, please read through this, very important. So your final for this class is next Wednesday, the December 15th, from 4:30 to 6 o'clock in BHCC 108. It will cover chapter 7, 8, 9, and 10. You will have 10 multiple choice questions to 4 to 5 open-ended questions in this test. Again, do the open-ended first before you do the multiple choice. You are allowed to use one front page of notes. So again, that you guys familiar with your midterm. So some kind of familiar to your midterm, but this is for chapter the last 7, 8, 9, 10 here. So make sure you guys start writing, something on this note here. And then we'll be reviewing today and Wednesday. So today is via Zoom. Wednesday is on face-to-face in BHCC 108, sorry, BHCC 108. And it's with the optional Zoom. So if you don't want to come to the Zoom on that Wednesday, you just need to log on to the Zoom here. We do not have class on Monday, the next Monday, which is what day was that? The 13th. So Monday, we don't have class, but you have a finals on Wednesday, okay? The review and the key is right over here. So you've on this in this attachment, so you can find the review and the keys. Today we will go over the reviews here. Anyone have any questions with this finals? Class.
I have one question.
Yes, Suli.
I have homework questions.
Okay, so beside homework questions, anyone have any questions on these finals? Right. So if you cannot take the test on Wednesday, please let me know as soon as you can, because I will be out of town on Thursday, the 16th. So you probably will be, if you take a test, you have to take a test earlier, either Tuesday or Monday on the 14th or the 13th. So this is very important that if you cannot make it to the test on Wednesday, on the 15th, you need to let me ASAP. Do not let me know by the day of the time of the test. Otherwise, you will be getting a big fat 0 in your finals. I think your finals is what, 30%? How many percent is your finals towards your grade? Let me see what is your final looks like. What is the syllabus? Your final is how many percent? Anyone look at the syllabus? Your final is 35% of your grade. So it's a big chunk of, so this is big here, okay? So your final is a 35% of your grade here. So please, 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 this is super, super important here, okay? So please study hard for this one, okay? All right, we'll talk about your homework. So Suli, what kind of questions, on the Nafisa, what kind of questions you have in this case?
Question 6 and 10.1.
So don't forget 10.1 and 10.2 is due this Wednesday. So this is your last 2 homework that you have to do. Question what again?
Question 3 and 6. For question 3, I'm having a hard time whether or not I'm focusing on the Y or X in order to determine those numbers, because
okay, we did question 3. This is 10.1, right?
yes.
So we did question 3 before, so I'm going to do this again. So beside question 3, what questions you have?
6.
We also did question 6.
I have a question.
Yes.
So question 1 of 10.1, there's a second part to it.
Mm-hmm.
Are we going to have something like that on the test?
Let me take a look at it.
Okay.
So question 3 and question 6, okay, we talk about that. So we'll do this again. This is a good review because question 3 will be in your test. Question 3, question 1. No, this kind of questions you won't get it in your test, Casey. So what is?
So it's asking like for an integer or decimal.
No,
rounded
this
to
is
one
not.
fourth.
Yeah, this is not going to be in your. So for this, so what is R and rho represent? So R in this case represent the what?
The value of the linear correlation coefficient computed from the paired sample data.
Mm-hmm. So it's A.
But well, the one that I got A.
R is a
for-
statistic.
yeah.
Yeah, looks like it
Yeah.
represent. I think
Yep,
this is
but
rho is
B-
a yeah. So this is good. Yep.
But B is the
B.
issue that I'm having with.
Okay, we don't. So this is not. You won't get this in your test on part B like this.
Okay,
So
but it
you don't. I don't
Yeah.
give you to type in this.
okay.
So
But I'm
how
having
you
issues solving
do
this
this?
one.
Yep.
Whoa.
Yeah, I'm gonna be people. So without doing any research, I can estimate the value of R here. So select the choices to be answered box, complete your choice here. So we are talking about body temperature and head circumference. So this is talking about, is body temperature and head circumference, are they related to each other?
No.
They are not related. This is
Yeah.
talking about, do you think the head circumference, your head, right? You think your head depends on your body temperature?
No, I
No.
don't think so.
No. So this one is, that means your answer will be C. So this one is going to close to 0. Okay.
Oh,
Because it's not related.
Oh, okay. I couldn't figure out
Mhm.
what, because like I understand that they're not related, but that whole number
Yep.
that they're looking for, I couldn't figure that out.
Yep.
Okay.
So if it's not related, means it's no correlation. No correlations means it's close to 0.
Okay.
Mhm. And then this is the one that what happens if you convert from Celsius to Fahrenheit? Do your R change? This one is important. So if you convert from Celsius to Fahrenheit, do your R change?
No,
So the R
wait.
value.
it shouldn't, right? Because it's still the same.
So your
Same
R
thing.
does not change because of what?
The conversion.
The conversion. So yep, this is true. So this is important. Okay. So if you do a conversion from Fahrenheit to Celsius or pounds to kilograms, whatever you're going to do conversion, your R will not change because if you convert your values to different scales. Okay. So yep.
Also, I remember you said something like we would have to convert it. Are we gonna have to do that on the
no.
test?
No.
Okay.
No. This is something that you get in your test. Means I do not want you to convert, but you should know that when you convert it to different scales, your R will not be changing. But if you
Okay.
really want to prove this, then yes, then you have to do it by, but no, you don't need to.
Okay. And then I have another question about 3, and I know you're going to talk about it, but I just want to confirm with you quick. So the higher the number, the closer the
Dots are.
dots are, right? Okay. I thought that's what you said, but I couldn't remember. Okay.
Mhm. So the higher the correlation, the closer the dots are. Positive means the line goes up. Negative means the lines go down. So Nafisat, this is question 3. Yes, we did this before. And again, these kind of questions will be in your finals. So I give you 5 scatter plots, and I give you 5 correlation coefficient. These are the 5 correlation, and you have to match them. So if you look at scatter plot number 1, Nafisat, can you tell me, is this scatter plot is having a positive or a negative slope?
I think negative.
Yep. So which one of these is the correct correlation for the negative slope? 0.996, 0.738, negative 0.397, 1 or negative 1?
So what I'm saying is, if it is negative 0.397, where do we point that on the,
Right here.
no, I'm saying, where is negative 0.397 on the scatter plot?
Oh,
Where
it,
is it?
no, it will not tells you that.
That's what I was looking for.
You do, this is how you spot this by just knowing this.
Oh,
So you are not plotting this in your StatCrunch and then run through the, no. This is, so I give you a scatter plot. The only thing you can do it is plot all these points, but that's a lot of work.
yeah, I was just.
Okay. So because they give you 5 of this and you know it's a negative, so you got 2 choices here. And we know it's not -1, so that's why your answer will be negative 0.397. So they only give you 5 of this, so you have to kind of use these 5 scatter plots by figuring it out yourself.
So you're basically looking at it and just kind of guessing whatever is the best.
Yes.
Yeah.
Yep. By figuring out how close they are and are they positive or negative slope. That's why every time when you do this, if I don't give you any coordinates, you have to figure out. So how about scatter plot number 2? Is the slope is positive or negative for scatter plot number 2?
Negative.
Negative, and they all line up perfectly. So what is your what is your correlation here?
-1.
It'd be -1. Yep. Okay. How about number 3? The slope is
Positive.
positive. So it's either 0.996, 0.738, or 1. Now we know it's not 1 because 1 means everything has to be lined up straight. So it's between 0.996 and 0.738. You think these dots, if 0.996, the dots should be what?
No,
Very
No.
close, right? Because this one
Yes.
is what we call as a strong correlation. So what you think about scatter plot 3 is
0.738.
so it would be 0.738. How about scatter plot number 4?
0.996.
It looks like it was a straight line, but you got a few points that is just a little bit off from that straight line. So if they are a little bit off from the straight line, it's not 1. This is 1 here for scatter plot number 5 because it is exactly a straight line. Okay, so make sure you guys know that you are not finding it. You are kind of figuring out. If I give you these 5 correlations and 5 scatter plots, you have to figure out which one is which. And you just need to know that negative means the slope is going down. Positive means the slope is going up. 1, if you get 1, means they are all lined up straight line. And if you, as what Casey mentioned, if you have a strong like 0.9, 0.8, your dots are close. And then when you get like 0.6, 0.5, your dots are a little bit scattered. And then when you got like very close to 0, it's all scattered around. Okay, this is how we figure this question out. Next question is question 6. Now, in order for you to do this kind of question 6 in your StatCrunch, you need to plot these points. Okay, so if you want to figure out, do this have a strong linear correlations, you have to plot your points out. So what you do here is you go to your StatCrunch and you have to plot out the coordinates here. So this is X and this is Y. So the first point is this point. So what is the coordinates of this point?
1.
X is 1, Y is
10.
10. So you do 1 and 10 here. And then you do the next point, which is this point. What is the coordinates of this point?
8 and 1.
8 for X, Y is 1.
1.
And then now you move up. So what is the coordinates of this point? X is 8, Y is 2. So you have to literally do this, and then same thing happens on this point. X is 8, Y is 3. So you do need to do 10 points here. So the next one is this one. X in this case is 9. Y in this case is 1. And then you do the same thing on the next one. X is 9, Y is 2. And then the last one is X is 9, Y is 3.
Does it matter how you plot the points on StatCrunch?
What do you mean by doesn't matter what you plot the point?
Because you started from like the bottom, doesn't matter if you start from the top.
Doesn't matter. As long as you give me the right coordinates. So you can start from this point to that point, doesn't matter.
Okay, thanks.
So the last one is 10, 1. So it doesn't matter. So if you're gonna start 10 first, you can do it 10, 2, and then 10, 3. So it doesn't matter which way you do, as long as you got these coordinates points, not in the correct order form, you're fine. And then you go to stat, you go to regression, simple linear regression, X and Y in this case. And then you compute. So this is a correlation here. And the question is asking that, is this correlation strong? So what is considered a strong linear correlation? What numbers?
0.07 to 0.09. So it
0.7 to 0.9. Yep. So this is 0.9 absolute value. So we don't care about the negative. So is this a strong correlation? The answer is yes.
Are we gonna have something like this?
I do not know. Then you need to find the R. So the R is given us by this question. R you find out by here. So this is negative 0.906. And then the question C is there a linear correlation? So you look at your p-value. This is the same thing we did. So the p-value in this case is 0.003. Is this p-value is what, less than alpha, right? So is there a correlation or there is not a correlation? Since your p-value is less than alpha, so what? So the answer is there is correlation in this case. We don't use the critical region. So usually this is not, if I come up in this test, you don't give me this, it's an open-ended questions, means you have to write it out. So the answer is, the reason why is this is a correlation, this is a linear correlation because the p-value is less than alpha. This is, you reject your null hypothesis, right? Yeah, so this is p-value, yeah, you reject it. So yes, this is in this case is that one. So again, mostly these kind of questions will be in the open-ended questions, means you have to write it out. And usually we use the p-value and alpha. And the last thing is, what happens if you exclude the 0.110? What is your R? So what you do here in this case is you will need to delete the 0.110 off. So this is what happens in your StatCrunch is you have to take the 0.110 and then you have to redo it again. So you go to stats, you go to regression, go to simple linear regressions, and then do the same thing X and Y. But this time you only have 9 points. You find out that your correlation in this case is what? 0.
I have a quick question for you about that, the p-value and alpha. I can't remember if you said we're supposed to have that on the test, or, you know, for...
We don't do critical region. We will do the p-value and the alpha. What do you mean by that, Casey?
So, I just want to know if I need to put it on my paperwork, on my sheet, so that I can, because you know how like you wanted us to put the p-value and all that stuff for the other chapters from chapter 7 to chapter 9. I just want to know if I need to have this on the test for
Yes.
chapter 10 and 11.
Yes.
Or 10 and, okay.
Yes. If you don't write down a p-value, I doesn't know what a p-value is. So you need to tell me what's a p-value.
Okay, thank you.
So you need to tell me if your p-value is less than what is a p-value is, and tell me if the p-value is less than alpha or your p-value is greater than alpha. And if p-value is less than alpha, you conclude that it's a linear correlation. Otherwise, you conclude that it's not a linear. So you have to tell me. Yep. Again, your test is very similar to what we did in here, where I will ask you for p-value. See that? I will ask you p-value, right?
Yeah, but this p-value is completely different from chapter 7 to chapter 9, and that's why I wanted
What do
to
you mean by
know.
well, it's just a different way to find it, but it's the same.
Yeah.
P-value is a p-value, no matter what chapter you go.
I know, but they have different meanings though. Like, because this one is like, it's either concluded there's a linear correlation or concluded there
correct.
is no linear correlation.
You are correct. Yep.
Okay.
That's the only thing for chapter 10. Yep. Yep. Chapter 10 is only this conclusion you have. Either there is or there is not. You are correct. Yep. So don't panic. Casey, you are correct. You're just panicking right now.
When it comes to tests, I get really scared. I want to make sure I have it correct. That's why. And
Yep.
I'm sorry that I keep asking.
No.
questions.
You just want to clarify it. So yes, chapter 10, the p-value is very straightforward. You do not need to do a lot of writings. Okay. Chapter 7, 8, 9 is different story. You have to know the tables, right? 1, 2, 3, 4, and p-value, reject or fail to reject, H naught. Those are
Okay.
different. Yep.
All right, thank you.
Right. Any more questions on your homework here? Anyone? All right. So yep, Casey.
I have a quick question about, I mean, I guess I can figure it out, but I just want to confirm something. It's number 4
On
10.1. So, let's see. I'm trying to do, so I click where it says click to view your table of the critical values for the correlation, right?
don't look at this.
Oh,
We don't look critical values.
oh, okay.
We don't do this. We never do critical values. Don't look at this.
Okay,
Don't look at this. We don't do this.
okay, thank you.
We look at the p-values. Don't look at critical values. As I told you, there are two things, right? Either you
Yep.
do the p-value or the critical value, right?
Yeah,
And I always do what?
the p-value.
P-value. Yep.
Okay, good.
So if you see anything with critical value, the only critical value questions you get in your test is in the review. I will show it to you in the review, but none of this is going to be in your, like the critical value like this. We don't do that.
Okay, all right, thank you.
You will see a questions in the critical value. So the only critical value questions that you get here is question number 13. This is the type of questions that will ask you to find the critical value in this case. This is the only part in your test that I will ask for critical value. The rest of the test,
Okay.
I will not ask for the critical value. I will ask for the p-value.
Okay.
Including chapter 10 and chapter, any chapters, 7, 8, 9, 10. This is the only one that will use critical value. The rest of them, all p-values. Right. Anyone have
Right.
more questions? All right. Before we start doing your reviews for the finals, make sure you guys know the difference of chapter 7, chapter 8, chapter 9, and chapter 10. Because when you do your online homework, chapter 10, we know is talking about correlation and regression. Oh, chapter 7, we taught this. Chapter 8 is that. Chapter 9 is those. But when you're doing a test, everything is mixed up. So you need to know the difference between these 4 chapters. Okay. So I kind of do a conclusion here. So make sure you guys pay attention here. So for chapter 7, we are doing just the confidence interval. Okay. And this chapter 7 is confidence interval for one population. That means you only got one group. Okay. We will either it is proportion or it is mean. Okay, either it's one population proportion or one population mean. Now, every time when I ask you for proportion, your sampling distribution is always Z. Okay, your sampling distribution is always Z. When you do the mean, the sampling distribution is always T. Okay, that's the difference between. So every time when you hear mean, I don't care it's a 1 or 2, it's always T distribution. This is very important class. If it's talking about proportion, it's always Z. Okay. Now, when we talk about the proportion, the requirements, remember we need requirements, right? Okay. So no matter it's a one proportion, a confidence interval, hypothesis testing, or doing two populations, the requirement is 1, it has to be simple random sample, short form SRS. 2, it has to be binomial. And then 3, it has to be at least 5 success and at least 5 failures. So when we talk about success and failure means you got 2 groups. One is, let's say, male, the other group is female. That means I need to have at least 5 males and at least 5 females. Okay, success failure. Okay. So these are the requirements for proportion. So no matter you're doing one hypothesis testing, confidence interval, anything to do with proportions, these are your requirements. You cannot change the requirements. The required.
Hello, Prof.
Yes.
Could you please remind me again, how do we know if it's binomial or not?
Binomial has 4 conditions here.
Could
You need to know N,
Okay.
independent. Binomial means 2 outcomes. And the success, probability of success is the same for each outcome.
Thank you.
These are the 4 requirements for binomial. So binomial has 4 of this. So you also need to check these 4 little things. Just count 1, 2, 3, 4, and then up. So that's the binomial. The requirement for mean is simple random sample. And your population is normally distributed, or your sample size has to be greater than or equal to 30. So this is the requirement for mean. So mean does not have a binomial requirement, and mean does not have the at least 5 success and 5 failures requirement. So mean has this requirement. So there are 2 different, simple random sample is a must for each one of this. But for this, the second requirement for mean is a little bit different from the requirement. So only 2 requirements. And what happens if your sample size is small?
Do a box plot?
Yes. So if you have a small sample size, like you don't have a 30, you got only 10 or 20, then you draw your box plot to check for outliers. Okay. If outliers, no outliers, good news. If outliers, bad news. Okay, so what we do is you're looking for the outliers case in this case. So box plot will show us outliers with a little dot on the far left or far right. So this is only happens for the mean part, not the proportion part. Okay. So this is the confidence interval here. And when you do your interpretation here, the interpretation is we are how many percent confident, right? That's the interval from this is what you guys need to know, very important. So this is how we interpret your confidence interval. We are 95% confident, we are 90% confident that the interval from search to search, because this is where you find your confidence interval using your StatCrunch, will capture the true value of the population proportion. Okay, so this is how you interpret confidence interval. The only difference about the mean is we still use the same interpretation for the mean, but we will use, instead of population proportion, we will use population mean. Okay, so it's the same thing. And then the only difference here is for the mean, we have unit. Usually proportion, we don't have unit. The only unit I might think of is percentage. But if you did not change that into percent, you know, just 0.38 to 0.55, you know. But if you change the percent, it's just 3.8% and 5.5%. You know, that is the only thing that you have for proportion. But for mean, you do have unit because mean is used for quantitative variable, like your height, test score, your weight, your temperature. So this is for a quantitative variable here, quantitative variable. So that's why when you guys read the question, you need to know, are we talking about categorical, which is the proportion here, or quantitative? Categorical means that you got categories, you only choose one of the categories, like male and female is categorical. Yes or no, something like that. And make sure it has two outcomes, because a binomial have this, you cannot do yes, no, maybe. Okay, so you may have to have two choices to pick. That is the categorical for proportion here. So you have two choices. You pick one. For mean, you do the quantitative variables like your height, your weight, your temperature, your test score, you know, everything that you can measure. Okay, so this is all talking about confidence interval. So that's why your answer in this case will be the confidence interval questions. Okay, so you have this is how we interpret. Now, chapter 8 is
Wait.
talking. Yes.
I have a quick question about the interpreting part. So you said when you were reading out that whole, you know, like we are blah 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 percent confident that the interval from so and so actually does contain the true value of the proportion. Do you, because I know sometimes you want us to be very specific. So for this one, are we just ending it at like the
Yeah, I'm fine with it.
Period. Oh,
as long as you know how to interpret, I'm fine. I mean, as long as you know what to do. And yes, usually you need to interpret behind population proportion of male who is right-handed, you know, something like that,
Yeah.
right? Yeah, if you want, you can do it. As I'm not that picky right now because you got so much things in your finals.
Then when do you want us to be very, because the certain chapters you kept telling us that we have to be very specific about the claim. Oh, that's what it is, the claims.
Chapter 8. Yeah. I'm
So
not
in chapter 8, you do want us to be very specific with the claims.
That's the hypothesis testing. That's
Okay.
why I'm doing this for you guys, right?
There's
This
so
is
much
hypothesis.
information. I'm getting
That's the
confused.
reason why, again, Casey, if you want, be specific, be specific. You know what I mean? Then if you want to save your behind, just be specific.
Okay.
Then you will save your behind. You know what I mean?
Yeah, that makes sense.
Yep. Just be specific. No, then if you want me to be specific, then I'll be specific. Then I will do ... behind. It's very easy. I just put ... behind. So when you see ... means be specific.
Okay.
So now like the population mean of test score of this class or something else. Usually it's in the question. Now, this chapter 8 is doing a hypothesis testing for one population. So this kind of questions will have the word claim on the test. Test the claim, test the claim, test the claim. So when you hear test the claim, that is where you will do hypothesis testing. And when you do a hypothesis testing, it's a 7 steps procedure. Okay, so this is a long one, and this is the one that gives you a lot of points. However, for chapter 7, it's not a 7 steps, just a straight go to the confidence interval, put it in your StatCrunch, and it will give you the lower and the upper, and then that is your answer. It's not a 7-step procedure for the confidence interval one, but for chapter 8, it is a 7-step procedure. Again, we will have proportion, and we will have mean. Now, what is chapter 8 is about is we are doing just one population. Okay, so this is very important for you guys because we will go do 2 population in chapter 9. Okay, so if you have one population, this is either chapter 7 or 8, depends, are you doing confidence interval or hypothesis testing. Now, the requirements for this is the same. What's the meaning when I say the requirement is the same? It's the same as this one. That means now for hypothesis testing for proportion, the requirement is simple random sample, binomial, and at least 5 success, at least 5 fail. They are the same requirement for proportion. Okay, but in all, this is the first step. The second step is to write your hypothesis. So H0 and H1. This is where P is equals to a P0. And then P is either less than, greater than, or not equals to P0. Again, P0 is your, what we call as a claim value. This is usually in your claim statement. Okay. The third step is asking for sampling distribution. Again, for all your proportion, your sampling distribution is always what? Z.
Mm-hmm.
And then fourth, you have to find your test statistic and your p-value. So you have to use your StatCrunch to do it. Now, when you guys are in your test, you will see that I will ask you for StatCrunch like this. What is the meaning when I ask you for StatCrunch? This was a point in your test. Is you have to give me the link how you get into the numbers. So for example, is in order for you to do this, your StatCrunch will go to stat. You're gonna go to proportion stats, one sample with summary. So this is the orders you have to go, right? Stat, proportion stat, one sample with summary. So what you do in this case, you have to do the same thing. You have to write stat, proportion stat, one sample with summary. Okay, so this is what a lot of you will see in my finals. I will say, what is the StatCrunch is? What does that mean in this case is how do you get your, where do you put your results? What link is that? You go to proportion stats, or you go to T-stats, or you go to the regression. You know, there's a lot of, is that a one sample? Is that a two sample? Or is that a pair? Or is that with summary? Or is that with data? So there are so many ways to get in, you know, once you click in, then you can enter your, you know, you can put in your numbers here, right? So, so this is what in your tests will ask for. You will see a big word, you will see a big word called StatCrunch. That StatCrunch is telling me what link do you go, where do you go to get to put in your numbers, okay? And then number 5 and number 6 is your decision and your conclusion. I think this one you guys are familiar with this one. P-value is less than alpha. We will reject your null hypothesis. P-value is greater than alpha. We fail to reject. This is, you guys familiar, right? You guys been doing this a lot. And then 6 is a conclusion. There are 4 conclusions you make. There is or there is not sufficient evidence to either support or warrant rejection. You guys know this, how to do this. I just leave it blank. And then the 7, the last part is the questions. This is optional, right? Usually the question in this case is either yes or no, depends on your conclusion that you make. Okay, so it's very straightforward type questions here. It's not like your online homework. Okay, the requirement for the mean here is also the same. Again, what do I mean by same? Here is the same as this requirement. So if you see the rate, that's why I put rate here. That means you only got 2 requirements for mean, simple random sample. The second one is population is normally distributed, or the sample size has more than 30. The number 2 is gonna be instead of using P, we will be using mu. Okay, because it's a mean, so we don't use P, we use mu. So mu equals to mu naught. Mu is either less than, greater than, or not equals to mu naught. Again, mu naught is what we call as your claim value. You'll find this in your claim statement. Next we have is your number 3 is the sampling distribution. So all the mean, the sampling distribution is T. So make sure you guys know that. And then the same thing happens to the stat 4. You need to give me your test statistic and your p-value. And again, I will also ask for stat crunch. Again, for the stat crunch to do mean, you got to go to stat, t-stats, one sample either with data or with summary, depends on the question. If a question gives us data like this, then you go data. If a question gives us the summary statistic like the mean, the standard deviation, and all those informations, then you do the summary. And I won't give you a test question that if you one part is summary, a summary statistic, and one part is data. No, I won't do it that. I will either give both of them are using data, like or both of them are summary statistics. I won't give you one of the other, like what your online homework do. Your online homework is more difficult than your test. And then, so this one you have to go to like stats. This is t-test. One sample. Then either you tell me either you use with data or with summary. So this is what you just need to tell me which one you pick. And then the same thing happens. Number 5 is a decision. Number 6 is a conclusion. And then 7 is a question. So this is, they are the same. Same. Cannot run away. Okay. Questions?
Can you read what number 4 is for the mean? I can't read what that says.
It's a test statistic and then p-value. And
Okay.
then for the, so it's kind of the same thing as this. It's very similar to this. You need to find the test statistic and the p-value. The only difference here is your test statistic will be written down as t equals to something. But for your proportion, the test statistic will be written down as z equals to something. So it's the same step. The only thing I will ask for is the stat crunch, means you have to tell me where is the link you put in. So it's under stats, t-test, one sample, either is with data or with summary. Okay. So this is stat, proportion, test, one sample with summary. So this is a little bit different. You go. So this is for what? For one population to do hypothesis testing. So chapter 9 is doing both confidence interval and hypothesis testing for 2 populations. So now you guys need to know that if the questions is given you into 2 groups or 2 populations, then it is automatically chapter 9. If they only break it into 1 group, then it's just either 7 or 8, depends on what you do. Okay. So again, this question will break into proportion. So it's 2 proportion here. Or we do 2 means. And I'm going to erase 10 here because I have no room for 10. I'll put 10 in the next page here. I might have, so we do 7, 8, 9 here. So to proportion, the requirements for this is the same requirement. Means simple random sample, proportion, binomial, at least 5 success and 5 failures for each population, because now we got 2. So you just need to do for one group, do you have 5 success and 5 failure? And then you do the other group, do we have successful 5 success and 5 failures for the other group? So the requirements are exactly the same requirement that we use. We didn't change the requirement. It's exactly the same requirements we talk about. For your if you do your hypothesis statement, then you just do mu1 is P1 is equals to P2. Then the alternative in this case is P1 is either less than, greater than, or not equals to P2. And then the rest is almost the same. The 3, the sampling distribution is still Z. Then you will still do the test statistic, which is also Z equals to something if you use your StatCrunch. P-value, same thing. StatCrunch, in the StatCrunch, you don't do one sample, you do 2 samples. So you do stats proportion, and then you do 2 samples with summary. So this is the only difference here. And then you do 5 and 6, the same thing, 5, 6, 7. So mostly everything you did is very similar that following your hypothesis testing. Nothing changed. The only thing you need to watch out for this chapter 9. So this is the thing you need to watch out for chapter 9 here, is confidence interval. Okay. So in order for you to find the confidence level, if you got a one-tailed test, you guys know what's one-tailed test, right? Either is less than or greater than. Your confidence level in this case is what? 1 minus 2 alpha. And if you have a two-tailed test, means you're equal with not equal. You guys know the two-tailed test. Then your confidence level is 1 minus alpha. This is very important because this is only for chapter 9. Because chapter 7 and chapter 8, I will provide you the confidence level. You do not need to worry about this. This is only for chapter 9. Okay, so that's one thing you need to know, very important. Next thing you need to know is also your confidence interval. So if your confidence interval shows both negative, what can you tell me? P1 is
less than P2.
Yep, P1 is less than. What happens if show positive, both positive?
It's greater.
So P1 is greater than P2. And the last one is what happens when show one positive and one negative? P1 is equals to P2. Okay, so this is again only for chapter 9, not for chapter 7 or 8 or 10. This is only for 9. Same thing here. This all this is only for 9s. Okay, so these are very important. 2 means, now these 2 means will break into 2. So in chapter 9, when you talk about 2 populations, the proportion is, same thing. But when you do 2 means, either they are independent or they are dependent.
For the confidence level interval, I can't remember. Do we do both? Do we look for both one tail and then we do the second confidence interval, which is minus and minus makes it P1 less than P2, or is it just either or?
What do you mean by either or?
So like, do we do both? Do we find both confident interval? Because there are two ways to do that. So I'm
You only
asking-
use one of this.
Yes, what about the one on the right?
You will get only one. If you find one, you only get one confidence interval. You pick one of this
Okay.
because you will look at your hypothesis testing. If you're doing one t-test, then we will using this. If you're using two t-tests, then we'll be using that. You only got one way to pick this. And then the confidence interval, you either get both negative, both positive, or one negative, one positive. We only got one of these choices. You don't get two. So, so for this case, for the two means, we got independence and dependent or match pair. They are the same thing. So how the requirements for this is the same requirement. So the requirement here is the same requirement. They are the same. What does that mean by the same requirement is the one that we just mentioned early on in chapter 7 here. Means the mean, the requirement is simple random sample. Population is normally or sample size is more than 30. But since you got two populations, then both of these populations has to be more than 30 or both populations have to be normal. So that is the meaning of the requirement. They are the same. So that's why the requirements is fixed. No matter which one, no matter one sample or two samples or whatever you're doing, the requirement here is a fix for all this case. Okay. The hypothesis testing is this is H0 is mu1 equals to mu2. And then H1 in this case is mu1 is either less than, greater than, or not equals to mu2. But for the dependent case, we use mu d. So mu d, the difference is equal to 0, and mu d is not equal to 0. So that is the difference between independent and dependent. Your sampling distribution is still t on both cases. Okay, because again, all your mean, the sampling distribution is always t. So that's why this is always t, always t, always t. And then for the proportion is always what? Z. Okay. And then you do the same thing, number 4 and number 5. Number 4 is where you give me your test statistic, your p-value, and then give me what is your StatCrunch is. Usually you go to stats, you will go to t-test with 2 samples, okay? For this, you will go either data or summary, but this one, make sure you pick the pair one. There should be a pair. So when you go to your StatCrunch, you go to stats, you go to t-stats, you go to 2 samples. This is for chapter 9. So with data with summary, this is for independent cases. For a dependent or pair, so you go match pair, you do the pair one. Okay, so that is how we do these questions here. And then 5 and 6, they all the same. Okay. Same decision, p-value less than alpha, greater than alpha, conclusion. You know, but make sure you guys know you can only pick one of this, and also very important that your conclusion from here and the conclusion you make here is match. So when you do chapter 9, the conclusion from hypothesis testing and the conclusion you make when you do your confidence interval, they should be matched. So that means they should be the same. So if you don't get the same conclusion in chapter 9 here, they are not matching. That means something is wrong here. Okay, so you did something wrong. So make sure you know that they all has to be matched. Okay, and then another thing I want to add on with this confidence interval, I think I brought up about what happens when you switch your population, right? So do you guys remember what happens when I switch your population?
Isn't it flip?
Yep.
Like
so your confidence interval will be flipped. flip and opposite. So flip in this case means the low become upper, the upper become lower, and then your sign, the opposite means your sign change, positive to negative, negative to positive. But I still want to point out to you that no matter what you do with the confidence interval, your confidence interval is always written down as like this. Okay, so it won't flip this one. Okay, so your confidence interval is always like that. So it depends on what you have here. It can be P for proportion. It can be mu for mean. If we talk about two sample, then it's P1 minus P2, or mu1 minus mu2, or mu d, depends on what kind of one population, two populations. But it's always low and upper, and the sign is always less than. So you don't flip this. You only flip the lower and upper, and you only flip your sign. That's it. Okay, so this is very important. And again, class, what I'm doing here is this is all only belongs to what chapter? Chapter 9, where we only do two populations. We don't talk about that in chapter 7, 8. So that's why, you know, kind of like a little bit separate, a little bit different here. Questions here?
You're telling us that because it's going to be on the test?
What do you mean?
That flip part?
Maybe. I'm not going to tell you what is on your test.
Well, you basically did. Like, you're like, hey, make sure this is, you put this on your sheet because it's going to be on the test. So you should just tell us right now.
I didn't say anything. Right. Last thing is chapter 10. So chapter 10 is where we talk about two things: correlation and regression. Okay. So this is completely different from 7, 8, 9. That's why I put it a little bit. What are the requirements when you do correlations and regression? The first requirement is make sure it is simple random sample. So the requirement is always one simple random sample, but make sure this requirement is going to be for quantitative variables only. Okay. So we cannot do correlation and regression with categorical variables, only quantitative variables. So when we talk about test score and remember last time we talked about chapter 10 about test score with attendance, you know, test score with how much time you work on your homework, how much time you study for your test, right? But test score. So they are all quantitative, but we cannot talk about test score versus gender, male or female. We cannot do that. The reason why we cannot do male gender here is because gender is not quantitative, gender is categorical. We also cannot talk about test score with party affiliation, Republican or Democrat, because Republican Democrats are categorical. So make sure when you guys do this kind of chapter 10, both, it has to be two, it has to be pair, it has to be pair. In this case, pair means together, and it has to be, both of them has to be quantitative variables. That is a first requirement. Okay. Second requirement is make sure that your scatter plot shows linearity. This is the very also important requirement here. What is mean here is if your scatter plot shows linearity, you will continue with this chapter 10. If your scatter plot shows non-linear, means like a curvy or like a parabola or something else, then you stop. And the third one is if you have any outliers, make sure you are extreme or we call it influential points. So if you have those cases, I will recommend you guys to remove it. Okay. But I will tell you, class, is in your finals, you do not need to worry about the third one because usually we don't have that. Okay, I already double check everything. So you won't have this. So the third requirements, you kind of like skip through it. Like, okay, we can skip it. Okay, but make sure these are the two requirements you cannot skip. Okay. Now, correlations, which is R, stand for. So R in this case has to be between -1 and 1. This is the first thing you need to know. So if your correlation is 2.3 or 3.8, there's no such thing. Okay, your correlation is always between -1 and 1. B, make sure you know that what is considered perfect, what is considered strong, what is considered moderate, what is considered weak, and what is considered no correlation. Does anyone remember this one? Casey kind of know this. Perfect means exactly what?
Oh, is it 1?
1. Yep. Strong means it's between what?
0.7 and 0.9.
Okay. And again, it can be 0.999. I just put a 9 underneath it. So around 0.7 and 0.9 is considered strong. 0.99999, I put it down there. Moderate is what? Between
0.4 and 0.6.
So I'll put 0.699999 means very close to 0.7.
Yeah.
And weak is considered what?
0.1 to 0.3.
99999. So again, I put 9 behind just to figure out that, you know, some of you say, what about 0.33? Okay. Still considered weak if you get 0.33. And no is what?
0 to 0.1.
0.1. Yep. 0 to 0.1. Yep. So you don't get exactly 0.1. So so you get very close to 0, more towards.
Yeah.
So this is perfect, strong, moderate, weak. No, this is count your correlations give you what we call as the strength. This is called the strength. Okay. Your correlations also tell us either it is a positive or negative. I think you guys know how to figure out if your correlation is positive or negative, right? You look at your slope. Slope is positive, positive. Slope is negative, is negative. Next, if you switch your XY around, your correlations is the same. So what does that mean is we got two variables, X and Y. Let's say X is your test score and Y is your attendance. Let's say your correlation for that is 0.8. And what happens if I switch X and Y means now the X is your attendance and your Y is your test score. Your R is still going to be 0.8, the same. Okay. And this is what we just talked about just now at the beginning of class. If you switch this with a different unit, what happens? Or you not switch, you convert. You do your conversion with a unit.
It still stays the same, doesn't it?
So conversion with the unit, R is still stays the same. You guys all right? Okay, so this is the correlations here. And then next thing we talk about correlations is your p-value. So this is the same thing we just mentioned just now. So your p-value is less than or equals to alpha. We say what? There is linear correlation. What happens if your p-value is greater than alpha? There is not a linear correlation. You guys all right here? So this is all about correlation. When you do regression, your regression equation is always y equals to b0 plus b0x. Oh, sorry. b0x plus b1 or the other way around, doesn't matter. But make sure you guys know that the one next to your x is your what? Your slope. And the one doesn't have an x is your y-intercept. So this is what we call as a regression equation. Again, there's a lot of name for this, line of best fit, least square line. But in my test, I will still do regression. And the class, I want to point out to you, when you do my finals, if you doesn't know what I'm asking for, please raise your hand. And I was walked by, I was like, David, what do you want me to do here? Is it calling me to find correlation or does it want me to find regression? And what is this line of best fit? I don't know what you mean by line of best fit. I will tell you, line of best fit is the regression equation. Okay, so if I can tell you, I will tell you that. Okay, because if I don't want you guys, but if you ask me, if p-value less than alpha, David, is that there is a linear or there is not a linear? Now that I cannot answer. Okay, because this you should know, p-value less than alpha should be there is a linear. But if you ask me this in the test, in the finals, I will not able to answer you back. But if you ask me what is correlation coefficient, oh, I say that's R. Oh, R. Okay, good. That I can answer to. But if you're asking something like, is this strong or is this moderate? Then I say I cannot tell you. Okay, I got R equals 2.56. Is this strong or is this moderate? Then I will say, I'm so sorry, I cannot help you with it. Okay, so make sure you guys know that sometimes some questions I can help you, especially with definitions. Say, can you tell me what is this correlation, linear correlation? I don't know what it is. I will say, oh, that's R. Or things like that. Okay, so make sure you guys know that I can help. If you raise your hand, I can swing by and let's see. If I say I cannot help you, means I cannot help you. If I can help you, I will say, oh yeah, this is what it is. I will help you with that. Okay, but mostly is definitions is the one that I can help you. Okay, what we can do with the regression equation here is to make prediction. Okay, what's the meaning when I say make prediction is you can substitute x equals to a number into this equation. Okay, but in order for you to substitute this, you have to have a good model. Okay, so when you guys did the last section 10.2, make sure you check the good model. What are the good models? The first good model is your scatter plot must show what? Linearity. Okay, so that is your first thing you need to check. B, your p-value has to be less than alpha, which in this case means there is a linear correlation. And then C, make sure there is no extrapolation. The word extrapolation means you try to predict something that is far away from your scope of your data. So usually in my test for the extrapolation piece, I either give you right in that scope of your X, or I give you way, way far away from your X. Okay, so so these are the three things that I will make sure you check. So if it's a good model, you plug your X into your equations, your regression equations. So if you got good models, means you go to this, good news. But what happens if you get a bad model? Bad model means you not fulfill one of these. Then you have to report what? Your Y bar. Okay. So if you got a good model, you plug it in here, then your answer will be Y hat equals to something. Okay. Don't forget class, the hat is very important. Because when you look at your StatCrunch doesn't give you the hat, it just give you Y, right? So make sure you have the hat on it. So this is the correlation and regression in this case. So very important to do this. Questions here in chapter 10.
I have one question. So when we have to plug the Y in, that's if there is extrapolation and it's a bad model, or just if there's if it's just a bad model because any of the points aren't fulfilled?
Any of these three conditions.
Okay.
Not just the extrapolation part, A, B, or C. Okay. So either one of this.
I
Got
have
it?
a question.
Mhm.
So for the perfect strong moderate weak, I know for strong is 0.7 to 0.9. Are we looking for a number that's exactly 0.7 or 0.9
It's-
or in between those
It's
two?
in between those.
Okay.
It's between those, and is for moderate is in between 0.4 and 0.6999. Weak is between 0.1 to 0.399, and no means close to 0. This is very important, and so the requirements are a little bit different. So make sure it's not the same as those requirements we just mentioned about.
And then you said if A is not linearity, then everything is bad model.
Yeah, ABC. If one of this does not fulfill, it's a bad model. One of this. All right. Let's take a look at your review for your finals exam here. So
I have a quick question. Do you remember you said something like if the requirement isn't fulfilled, then you would just stop, right? You're
we
not
will
tricking us.
we will
Oh.
continue. So
Alright,
no
okay.
matter, Casey, you are just taking the first statistic class here. If you're taking 20 statistic class, you should know what you're doing. This is your first statistic class. This is why I'm going to tell you, no matter it's chapter 7, 8, 9, or 10, I don't care what chapter you are, this is important. This is your finals.
I know. I'm
You
trying
know.
to figure out if you're going to like have some kind of, like
I'm not
I don't want to say trick because I know that you said that yours aren't like the homework,
Yep.
but I feel like the homework kind of tricks us.
Yes.
So that's what I'm trying to figure out.
Yes, your homework is a tricky one. I'm not. So if your requirement does not fulfill for chapter 7, 8, 9, and 10, you still continue.
Oh, and then do you want us to put that it's not fulfilled?
Yes.
Okay.
Don't just say, oh, requirement is this and this. That's it. Let's move on to next. Make sure you say requirement is fulfilled or not fulfilled.
Okay.
So in the finals, you make sure you do that. Okay. So, but the question is, if your requirement does not fulfill, you just have to continue doing the whole 7 steps of hypothesis testing.
Okay.
Otherwise, you lose a lot of points in your test.
Okay, sounds good. Thank you.
Because the whole test is going to be like, the hypothesis test is what, 7 steps, right? It's going to be 10 points.
Yeah.
So if you lose, if you don't stop there, if you stop there, you will lose 8 points or, a lot of points, I can tell you that. So please continue. Yep. So
you said, okay, I know that the majority of the ones that we were going through is only like 6 steps. I know you said that there's 7, but
Questions.
Yeah, if there isn't like a 7th step,
then
do you just
no,
leave it?
Yeah, leave it. If there's
Okay.
no questions, leave it.
Okay.
So the 7th step is optional, depends on the questions. Okay. I can tell you that maybe one of them have question 7, the rest is mostly doesn't have it.
Okay.
Yep, just read through the questions, they will tell you that. All right,
Okay.
my main part of this class is to read this question and telling me, is this question 1 come from chapter 7, chapter 8, chapter 9, or chapter 10? You got the review here, right?
7.
And then when you look at chapter 7, let me pull up chapter 7 here. You also need to tell me, is that proportion or is that mean? Because if you remember, when we do chapter 7, we have either proportion, the green one, or the mean, the red one, right? So if you tell me, so read this question and then tell me, yep, I'm going to take attendance here, so go ahead and put in the chat room. Yep. So tell me what chapter is this? And then tell me, is that proportion or is that mean? And what tells you that chapter is 7, 8, or 9, or 10? And then what tells you in the questions? And then why you say it's proportion or why you say it's mean? What in the question tells it? You're looking for keywords here. That's why when I give you the test, we are looking for this kind of keywords. So can someone tell me, you say this is from chapter 7, right?
Yes.
So where is the keyword for chapter 7?
Proportion, the percentage.
Okay, so this is chapter 7 on proportion. And what is the keyword we are looking for? Percentage, very good. Lawrence, that is one word. What else is also from chapter 7, the word what? Confidence interval. Okay, so if you have a confidence interval, and this is for one population, then this is going to be for chapter 7, and the percentage, it means proportion. So you're going to do this. So if a question, so the sampling distribution is Z. The requirement is simple random sample, binomial, and at least 5 success and 5 failures. And in order for you to put it into your StatCrunch, you go to Stat, Proportion Tests, one sample with summary. So this is the StatCrunch you do. So can someone tell me what to do with this question number 1 here? It's a lot of things to type. So this is chapter 7 proportion. I just shortcut 7 prop. So the first thing you need to tell me is requirements. So what kind of requirements do we have? It has to be simple random sample. Do we have that?
Yes.
Yep. On the question here, it's random selected. 2, it has to be binomial. Do we have that?
Yes.
We know n is 669. It's independent because when you talk about accidents, it's totally independent. You cannot, you can figure accident, but usually it's independent. 2 outcomes, either you die in an accident or not. This is talking about either you die or not die. The probability is the same, which is 50-50. So this is binomial. How about the third requirement? At least 5 success and at least 5 failures. Do we have that?
Yeah.
Yeah.
We also have that because 225 is accident, so that is the success is 25, which is more than 5. And then how many failures? You just subtract 669 from 25. We know that number is 600 some numbers. So that number is more than 5. So in this case, the requirements met. So this is how you write down in your test to see if your requirements met or not. Okay, so this is a requirement. Next, we do the sampling distribution. So the sampling distribution in this case is going to be what?
Z.
Z. So all proportion is Z. Okay. And then thirdly, you just need to tell me what is your StatCrunch. So the StatCrunch is go from stats to proportion stats to, I have no room, I just write down here, one sample, right, with summary. You can shortcut like this, I understand. Okay. Especially you're running out of time. So what you do here is you go to your StatCrunch. This is where you follow, right? You go to your stats. You go to your proportion stats. And then go with one sample with summary. And you're going to put this number. So can someone tell me what number should we put in here? Number of success is what?
25.
25. Number of observations?
669.
669. And we are picking the confidence interval. And what percentage is this?
98.
98. Okay. So you do not need to do 1 minus alpha or 1 minus 2 alpha here because only chapter 9 needs to do it. So if it's chapter 7, you just do whatever they're asking you for. So your answer in this case is the lower and upper that you found here. So your answer in this case is 0.02 to 0.05. I've just, so this is your answer. So your answer in this case is your 98% confidence interval is 0.02 and 0.05. Again, I don't really care. If you want, you can give me like 3 decimal places, 5, 4, and 2. Yeah, 20. Is I really 2 or 3 decimal places is usually what I'm asking for. Don't round to 1. Usually 2 or 3 is what I'm asking for. And if the question wants you to interpret this confidence interval, so you have to read the question carefully. If a question says, please interpret this confidence interval, how do we interpret this confidence interval? We are what? This one, right?
We are
We are
98% confident that the
that
interval
the word
from
from
0.020
to 0.054 capture the true value of the population proportion. And then if you want to elaborate, just look back at the question. What is this population proportion about? About what? All deaths that are caused by accident. Okay, so you just, like your claim statement, this is your claim statement. So you just copy and paste the claim. So now do not forget that because this question is asking for percentage. So whatever you give it to me has to be in what form? Percentage. So you cannot use this because this is not percent. So can someone convert this into percent form? This is 2%. And this is what? 5.4%. Okay. Again, I'm not taking points off if you don't convert to percent. I'm not that picky like your online homework. Just to point out to you when you guys do this in your multiple choice, if I ask for percentage, you will see me putting all your choices all in percent. So make sure you guys know how to convert this in percent. You guys all right here? Anyone have any questions? We are doing the first question. Right. I'm going to do question 3 because we're going to move things around here. I want you guys to read question 3 and tell me what chapter is this? And is this proportion or is this mean? Question 3.
It is mean, no doubt about that.
So this is mean because it has the word mean on it, right?
Yeah.
And what chapter is this on?
I think it's chapter 6, chapter 7.
This is still chapter 7 because the question is asking us for what? Confidence interval. So confidence interval for one mean, this is one mean here. This is chapter 7. So in this case, we are looking at chapter 7, confidence interval, the red one, mean, the left red one. Okay, and if you doesn't know this, you can also tell this is quantitative variable because you are talking about test score. Okay, your final score. This one that we talk about here is categorical because this is either you die from the accident or you don't die from the accident. Your death is from the accident or not. So this is yes or no. So that is a categorical type, number 1. Number 3 is a mean, it's a quantitative type. So again, we're going to go through this. First thing first, is this a requirement check? It's a simple random sample. So is this simple random sample?
Simple random sample.
So the requirements here first is simple random sample. We have that. And then the second one, the requirement is says your population is normally distributed or your sample size is more than 30. Is that good?
Yes.
Yes, because our sample size is how many students? We got 30. Actually, 30 is not a good one. I should need to erase. Sorry, I have to erase something here. So it should be greater than 30, not exactly as 30. Again, in the test, I will not give you exactly 30 like this one. So I will erase this. So this is actually, it's just more than 30. Sorry about that. So if you guys have, so this is actually is more than 30. Let me erase this fellow. So it's
So
not,
if it is 30, like what's the answer though?
it won't be no.
No, but I'm
30
just
is-
like, if
30
it's
is not
30.
more than 30, right?
Oh, so it wouldn't be equal. Like
It
would
wouldn't be
always
equal.
have
Yeah, I had to get rid of
Okay,
the equal
I
sign.
get it.
Yep.
Oh,
Okay, so in this case, this is not good because 30 is not equals to 30. So actually your requirement here does not met. Should be more than 30. Okay. The reason why if we cannot do box plot here is because I don't give you the data. So usually I will put the, if this happens, I will put a little here. I say, assume the box plot shows no outliers. Usually I will do something like that. But if I didn't say this, then you just say the requirement does not met. You still need to continue doing the rest of it, right? As I told everyone in this classroom. So if you did not met your requirement, if one of the requirement does not met, you have to still continue working on your, on your work. So what is your
Okay.
sampling distribution here?
Hold on. Can you repeat what you just said about the assume the box plot shows no outliers?
Because if you have a small sample size,
Yeah.
your box plots must show no outliers. I need to
Oh,
add
okay. So
more
you're
things.
you're telling us that it's automatic. Okay.
Yeah, I will try my best
okay.
to, what I'm trying to do here is I try my best to do what? To make the requirement what?
Yeah.
Meet. I'm trying here. So
Okay.
the reason why is because if I have this, a lot of students say, oh, David says requirement not met, I stop, no more.
Yeah.
Okay, so I'm in the test, I'm trying to do all these things so that I really want to push this to meet. You know what I'm saying?
Yeah. Yeah.
Mhm.
I get what you're saying, but I'm confused with the whole assume the box plot shows no outliers. You're basically just giving the answer, so we just bypass that.
Yeah.
Okay.
Yep. So if you see the assuming means you kind of bypass it. Yep.
Okay. I think I'm just overthinking things.
Yep.
Thank
Don't
you.
overthink. Do not overthink. I'm doing all this work is to make your life easier so you don't overthink things. But if you are taking this as a 5th statistic class, oh yeah, I'm going to make so complicated that you will not going to be. Yeah. This is your first one, so I'm not want you guys to overthink anything. You know what I'm saying?
Yep.
Because I don't no point. It's your first class. If you take this your 5th, if your major in statistics and you're doing this your 5th stats, higher level stats class, oh yeah, boy oh boy, yeah, I will flip you around and your brain will be going 360 off, rotate like crazy, and it'll be so fast. I will teach you. Yep. But this is your first class, so that's why I'm not gonna give you guys difficult words. So don't overthink things. If you overthink it, you probably do it wrong. That I can tell you that. Sampling distribution is T because it's a mean, so we do T here. So the third one is your stat crunch. Your stat crunch, you need to go to stat. You go to t-test. You go to one sample. And this one, you're going to go with summary because the question already give you the mean, the standard deviation, and all those things. So your question here is asking you to find a 99% confidence interval. So again, we just go to your StatCrunch. You go to the stats, go to t-stats, one sample with summary. So this is what for chapter 7 for mean. So the mean in this case is given by 79. The standard deviation is 11.7 and the sample size is 30. And we are doing the confidence interval for 99%. Okay. So when you compute this, again, this is your lower and upper. So this is your answer here. So it's 77. You got units. This is about test score, right? This is talking about your scores. So mean score. So you're going to forget your units is score here. So if you guys want to do like what you did in your midterms, if you get I'm taking points off, just make sure you put unit in this class. In this is all score. So same thing what you did in the midterm. So I won't take points off. So the 99% confidence interval in this case is given us by what? So this is what happens when you got one screen. 73.11
And 84.89.
and 84.89.
4.89.
And then if a question do want you to interpret this confidence interval, then you do the same interpretation like what you did in number 1 here, which will be we are 99% confident that the interval from 73.11 to 84.89 capture the true value of the population. Make sure you use the word mean. If you doesn't know its mean, you just follow the question. It's confidence of the mean score of all students. So this is your the one that you copy and the dot in here. Okay. So this is how we do this kind of questions. Again, class, I am not going to be as tricky as it can. The only thing that is tricky is the multiple choice, which you guys kind of know about it. So make sure you read the question on the multiple choice. Sometimes I want you to do the opposite. So what I mean by opposite is this is, let's say this is talking about those who have caused by accidents, right? So sometimes I want you to find the confidence interval of those who are not caused by accident. So you will see the word not come up. So you just do so it's 25 people die from the accident. So how many people do not die from the accident? Well, not caused by accident. So you just subtract those two, right? So 669 minus 25. So we'll talk about that in your Wednesday class about your multiple choice, because that's all worth 1 point. That one is a bit tricky, but mostly in my open-ended questions, it will be more towards like this kind of questions, very straightforward type. Okay. All right. So that's it for today. We're going to stop here. Anyone have any questions for me? If you do, stay. If you don't, you may leave. I'll definitely post this in D2L. Yeah.